Hello and welcome to another Solana tutorial. Today we're gonna go through part 2 of module 3 of the Solana development course, and we're gonna create a basic program. Part 1, handling instruction data. James, what are we gonna learn today? By the end of this lesson, you will be able to assign mutable and immutable variables in Rust. So that's some Rust basics for you and some programming basics, really. Immutability, you might have heard about that in the context of NFTs. Remember, the mutable NFTs are the ones that can be changed, but the immutable ones are the ones that stay like this forever. And it's the same for variables in Rust. Speaking of Rust, we create and use Rust structs and enums. Oh great, this time we'll learn about enums, that's good. We use Rust to match statements. Wait, no, we use Rust match statements. Add implementations to Rust types. Ooh, Rust types, hey? Now that's interesting, because I don't know 100% what that really means. But we will find out. Deserialize instruction data to Rust data types. Oh, now I know what it means. So that's the same thing that we had on the TypeScript side, where we define a thing and then we serialized and deserialized that, and we're gonna do the same just on the Rust. Execute different program logic for different types of instructions. Well, that's helpful because one program will always have one entry point, as we learned last time, and if we want to execute different instructions, then we kinda need to use this match statement to define what logic we want to execute. And then explain the structure of a smart contract on Solana. Yeah, Solana program structure. Well, I'm interested to learn about that because I don't know much about that yet. So let's lean in and start today's lesson. So the TLDR is programs support multiple discrete instructions. So you don't need to deploy a separate program whenever you want to have a different instruction, right? So it makes sense to have one program to be able to execute different things, and that is handled by the individual instructions. And we decide what those instructions do, right? We decide what data we receive and when an instruction is executed. Rust enums are often used to represent discrete program instructions. And then you can use the parse, create, and the derive attribute to provide parse deserialization and serialization. Yeah, so as we had it in the front end, we use the parse library to serialize and deserialize. In Rust, it's in a crate. As we learned last time, what that is, just a library. Meh. Rust match expressions have create conditional code paths based on the provided instruction. So that's just a switch statement, as you might know it from different programming languages. Like, in Java, that's usually a switch statement. Let's get started. One of the most basic elements of a Solana program is the logic for handling instruction data. Oh no shit. The most basic element of a Solana program is the handling instruction data. I don't even want to say any more of that. Do I? Most programs support multiple related functions. So it's not completely different stuff, but it's like somehow related, so that it makes sense to put it in one program. And we use different instruction data to determine which path to execute. We've seen this before in previous tutorials. There might be one byte which says which of the functions of this program should now be executed. So for example, you might have a function to create a new piece of data and then to delete some data, and you want that to be handled by the same program because they operate on the same struct, so the same data format, but you want the program to be able to create a new one and delete it. So you just need to say, please do the delete stuff, or please do the create stuff, and you do that with instruction data. Now, simple instruction data is provided to your program's entry point as a byte array. So all of the instruction data we get into our program as just a slice of bytes. Yes, using the word slice, because last time I learned what that means. It's common to create a Rust data type to represent instructions in a way that it's more usable throughout your code. And that mainly means it's more readable. If we have a data type that represents all of the instructions, then we can easily match them. Good. And in this lesson, we will learn how to do that. Rust basics. Oh, great. Some Rust basics. Starting with variables. We're not gonna backtrack that far that I'm gonna explain to you what a variable is. It's a thing that stores some data and is not constant. It's funny because variables per default in Rust are constant. Anyhow, if we want to create a new variable in Rust, we use the let keyword. Let age be 33 because I'm old. That's why. And here's the thing. Per default, variables are immutable, means they cannot be changed. So if I let age 33, I can't be like age 34. That won't work. For this to work, if I want to change the variable, I need to explicitly mention to Rust, I want to change this in the future. So I want this to be mutable. So I need to say mutable age 33, then this will work. And again, that has to do with how Rust deals with the memory management, because if it's a constant, like if it's immutable, then it's much easier to, give it around. And for instance, if we put it in a function, we know that it cannot be changed. So we don't need to worry about that. It's the same way why we also need to define our accounts as writable to C level, so to the Solana virtual machine. When we invoke a transaction, we need to say which of the accounts are writable. And similar thing happens for variables in Rust. You need to say, this is one that I want to write to. And the Rust compiler makes sure that if it's an immutable variable, it can really not be changed. That's already taken care of on the compile side. So at compile time. Per default, the way we code, usually we try to use immutable variables. Like also if we do TypeScript, we also do const and not var. It's so funny because variables are the opposite of constants. But anyway, whatever. It's just called variables. We are trying to use immutable variables as much as we can. Only sometimes it makes sense to use mutable ones, like if you have a counter. But usually the running variable for a loop, or like if you actually want to change some storage in the account, you need to make that mutable. But when you're dealing with references and you just create yourself a variable to hold that reference, it makes more sense to keep it immutable. So as a rule of thumb, you only want to write this mute if you really need to change it. Because obviously you could just define all of your variables as mutable. That would also work, but you're losing those compiler guarantees and essentially you make yourself more prone to error. And also there might be a difference in efficiency, but mainly only use mutable if you really need it. Moving on. Structs. A struct or structure is a custom data type that lets you package. Same as in C, right? If we write our own struct, it's a data type that holds other data types, right? It's a collection of data types. So if we have two elements that belong together, for instance, if we make a struct of a vector that has an x and a y coordinate, then those x and y belong together. Of course, we could make two variables, x and y, but since they always belong together, we put it in a struct and say the struct contains x and y. And then it's one data type. That's structs, easily explained for you. In other languages, that's classes. You use classes to do that in object-oriented programming languages like Java. But yeah, pretty much the same thing. Classes also have functions, but that's whatever. Structs are essentially classes without the functions that make up a meaningful group. Yes, they need to make up a meaningful group. Needs to make sense that they belong together. Each of the pieces in the data can be of different type. Yes, it's not an array where all of the elements need to have the same type. No, it can have different types. And we have a name associated to each of the elements in the struct, the so-called fields of the struct. So that's the definition of the struct. And then to use it, we just create a variable and say it's this struct, and then we can give the actual values. That's super similar to what I just taught in object-oriented programming to my students. This is the class definition and that's an instance of the class, a so-called object. But here we're in Rust and we're not object-oriented. We're using structs and we create a struct. Is there a name for that? A struct instance? Anyway, so that's the variable of type struct. And the difference is here we have the actual values for each of the fields in the struct. And then if we have the struct variable, if we want to just access one of the fields inside it, we can use the dot to get this field. Also very similar to what we have with classes. Pretty much always the same across programming languages. If you've been programming in other languages before, that should be readable. It's also the same in TypeScript, by the way. We also use the dot to access it, right? Cool, so that's structs. Moving on to enumerations or enums. With an enum, you can define a new data type that only allows certain states or certain values for that type. So for instance, I can have the enum light status and the only allowed values are on and off. So that's a binary thing. I only allow those two. So when my variable is a light status, then I can only put in those values. Same as if my variable is a bool, then I can only put in true or false. If my variable is a U64, then I can only put in 0, 1, or 2, or 3, or 3, until 2 to the power of 64 minus 1. Those are all the allowed values there. And the compiler checks that it's of this type. And the compiler here also checks if it's that it's of this type. And in Rust, we can embed values to those enums. Similar to what we had with the fields in a struct earlier, we can say the on state has the field color, which is of type string. And you might remember this from last lesson when we looked at what a program returns. Program result, which had the OK and the error, and the OK had a string like success, and the error had an integer like the error number. So those are the embedded values for this result enum. Coming back to our lesson today, if we then want to create such a variable light status, so that again is the instantiation of one of those enums, we can say light status with a double colon and on. And since this takes one element color or one field color, then we can say color is this. That's how we would create one of these. And James says it requires also setting color. So we cannot just use the on without the color because it's defined as this value must be of this struct essentially. So this has an internal struct here, which has one field color. Right, moving on to match statements. Very similar to switch statements in C and C++. That's what I said already, yes. The match statement allows you to compare values against a series of patterns. So we can match coin, which is a enum. There we have 4 of them defined. And then for each of the values of that coin, there we do the match. So that's a match with an enum already. You can also do the classic match with just an integer, like a U32 or something. But in this case, we are already using an enum because that's what we will need, or that's what we will usually do when we match for the instruction that we want to execute. The match statement must include all possible scenarios, otherwise the code will not compile. Yes, but there might be a default. Let's check the Rust book again. Okay, so we can apparently just use any variable name and then in this case puts it in the variable other. And if we don't want to use that variable, we can just use the underline, such that it doesn't complain. So that's for all other cases. Learn some more Rust syntax about the match keyword. Now to implementation, the impl keyword using Rust to define a type's implementation. Now that's interesting because I don't actually know this. Functions and constant can both be defined in an implementation. So I think this is very Rust specific, at least. Or is that what makes the struct more like a class because we give the struct functions or methods? So basically we implement the struct, essentially giving it functions, which makes it a class in my conceptual head. There we have it. The analogy continues. The function boo here can only be called on the type itself rather than the instance of the type. So that's very similar to Python, where the first element we reference the self. That's how Python does methods of classes, by putting the first function argument the self. So if we don't have the self here, then we execute it as a static method on that example struct. Guessing which words to use because several programming languages. So like compare in Java, that would be called static, where it's based on the class itself, or in this case, we have structs. So on this struct, on this example, you can directly call the boo. If we have a self here, then we need an actual instance of this struct, like so. We need to create this, and then we can call answer on this. Note how this function does not take anything in here in these round brackets, because the example itself is already provided before the dot. And that example essentially goes in here now. So this must be a mutable example reference. So self referencing to example must be mutable. That's why we have the mutable here. If that wasn't mutable, we couldn't call that. We could only call the get number on an immutable example. In case you haven't seen that, this is what it returns. So it returns an I32, so signed integer, because the number is an I32, a signed integer. So that there we basically say what the return value is. Again, different programming languages define that differently, but it's similar to TypeScript with the double point, so the colon, and then what it returns. Here we just have this arrow, this minus greater than, and then we say the type that it returns. So this implementation essentially contains the methods of this struct. That's how we can think about it. But it's called implementations. It's implementations of this struct. Oh no, you do call them methods. Unlike functions, methods are defined within the context of a struct or an enum or trait. So yeah, you do actually call them methods. Cool. So this impl is a method. The area is a method in the rectangle struct. Automatic referencing and dereferencing. We don't need to call that dereferencing operator like C has it, where we need to first dereference it so we can use the dot. Rust does that automatically when you call a method. Even from a reference, you can use the dot. So this is done automatically. So essentially, whatever is given as the first argument, either a reference to self, a mutable reference to self, or just self, Rust will then automatically reference or dereference it to adhere to this, whatever you write here. If that's a reference, it creates the reference. So you don't need to create a reference of the example here before being able to call answer. And that's just done such that it is easier to read, and it can be done because it knows what it expects here. So that's pretty cool. Nice. And of course, like in Python, if you want more arguments to your method, then you just put it after the self, right? If in here we would put more arguments, then in here we would need to, provide those arguments in the round brackets. But I guess that's understandable enough. So moving on. You won't be creating your own traits or attributes at this stage. So we won't provide an in-depth explanation. However, you will be using the derive macro. So it's important that you have a high-level understanding. Let's get a high-level understanding of this stuff. Traits describe an abstract interface that types can implement. Right, so that's essentially something like an interface in other languages. So an abstract method, is it that? If a trait defines a function, and a type then adopts this trait, they must then implement the function. A trait is essentially an abstract function that we know from C, or an interface that we know from Java. So a trait, essentially, we say trait, the name, and then we provide the methods, but we don't provide the implementation. We just then stop it and say it just has to have a summarize method and it needs to return a string. So we provide the name, all the arguments if there are more, and the return type, but no implementation. That's a trait. And then if we implement the trait, so we implement trait for our struct, then we actually provide the implementation, right? So that's containing the implementation now. And that makes sense if you have several structs implementing this specific trait, so that from a higher level, you always know that this method can be called and it will take the correct implementation depending which type of struct it is. It's pretty cool. Can provide a default implementation though. Still makes it a trait, but you can provide a default implementation. Okay. Again, I can recommend checking out the Rust book for more information. It's not a new concept. Other programming languages have that too. It's just that it's called trait here in Rust. And then attributes, they add metadata to a type. When you use the derive attribute, then you provide one or more supported traits. Code is generated under the hood to automatically implement the traits for that type. Looking forward to that example. Attributes, let's find attributes. The derive attributes generates code that will implement a trait with its own default implementation. Must admit, I don't fully understand this yet, but we're here to learn. I want to understand this. Let's continue our lesson and maybe we'll find out. So, representing instructions in a Rust data type. Now, from all the Rust basics, we want to go to the Solana stuff. So this is how we would now create an enum for different instructions. So it's essentially make a new enum, call it whatever my program instruction, and then provide the specific instructions. So those are the 3 instructions that can be run. And then we add the additional input parameters, so the additional instruction data that we require for this specific instruction. It's all done with those enums and the specific, fields. So that's an example that James made here with a node. We can create a node, update a node, delete a node. If we delete it, we just need its ID. If we create it, we need the title and the body of the node. And if we update it, then we also need to know the title and the new body. And with that information, we can then actually do the things that we want to do. Creating, updating, and deleting. Let's deserialize this instruction data because we have the enum now and we have what it takes. We have what it takes. And now we can deserialize that from just our byte slice. Because remember, the entry point just gets the instruction data as a byte slice. And we want to then unpack it somehow. So let's look at that. There we come to the attribute. Oh, finally we're gonna learn how this works. From this byte array, we now need to deterministically convert that array into an instance of the instruction enum. So we have the byte slice and we want one of these. We've used Borscht before. Now we use it on program side with the Borscht crate. And this crate has traits. Let's check this out. The Borscht crate has serialize and deserialize. Some docs, deserialize. It has the try from slice. I wanted to find the traits that you can apply to your types using derive. So does this derive essentially just give me those traits? I mean, yeah, that's what it says. Create provides traits. So essentially, I get all of those traits that this Borscht Deserialize has for the U8, the I8, for all of the types essentially, even like nested types like slices, arrays, everything, every possible thing that you can think of. Well, probably there are exceptions, but most of the standard things you get. And then it probably has a default implementation for all of those things. For the U8, for instance, it looks like this. If it's not empty, take the first element of this buffer and keep the rest, I think that means. So my new set my buffer pointer for the next thing to the remaining, but the 1 byte is my result. So that's how you deserialize a U8. And if you were to deserialize, I don't know, a U32, then it's like 4 bytes. So that's implementation for integer, which does the same from LE bytes. And then you have the size of that particular type. So that type is U32, so that would be like 4 bytes. And then you do the same thing, except that we don't have the 1 here, but we have the size, right? Like for each of the integers respectively. That's pretty cool. Anyway, that's already going very deep into the source code of Rust. Essentially, if we use the derive and this particular thing, then we get the implementations for all of those types from the Borscht Deserialize. So all those traits. The derive attribute to apply that trait to the struct. No, so this entire thing, hold on. This entire thing itself is the trait. That's the trait which holds methods and default implementations. And this implements the methods defined in here including the try from slice that we'll be using. So we now just need to make sure that this structure here is like those things are the same things that we expect from our input data, the instruction data. So the instruction data, when it's serialized on the client side, should be exactly those things, containing the ID, the title, and the body. And before that, I think another byte for the instruction. All right, and now it's common to write an unpack function that takes all the instruction data and returns us one of those deserialized things. Most native Rust programs on Solana just use the first byte to indicate which instruction to perform. So the first byte is an identifier, could use an integer or a string, and we will be using just a byte, so an integer 0, 1, 2 for our instructions create, update, and delete. Our unpack method for the node instruction, again, so the node instruction, we had that up here, that's the enum that defines our possible instructions. And then the implementation, we create a method, we can name it whatever, but usually you call it unpack. It takes the input slice, so that's the instruction data that it gets when the program is invoked. Essentially what we do is we split first, so we get the first byte into our variant variable, and the rest of the instruction data is, so that's essentially what similar to what we saw in the implementation here, something like give me the first and this is the rest. Similar, this thing works with give me the first byte and the rest. This is still a U8 slice, and this will be a U8. And if that doesn't work, then we throw an invalid instruction, data error. And then with the rest, so that is now just that thing that we have here, those things, we just use the try from slice that we got because we derived this borscht deserialize. So that essentially does the borscht deserialization based on, all the implementations here. And unwrap, what does that do? I don't actually know. And now we can use that first byte to match which of the enums we want to return. If it's a 0, we want to return the create node. If it's a 1, update. And if it's a 2, delete. And here we have the in all other cases, because again, the byte here has more possibilities than 0, 1, and 2. So we need to have this here, the other, but we don't need the variable itself, because in any case, we'll just throw an error. So we use the underline in any other case, or the default case is that we just throw an error. It must be 0, 1, or 2. And for each of them, we essentially, from the payload that we have unwrapped here, we take the title, ID, and body, put it in there. Sometimes we only need the ID, and sometimes we need the title and body as well. And then we essentially return this. And we return this because there is no semicolon, right? So the result is either a self, so it's either a node instruction, or it's a program error. There we return program error, there we return program error. Don't 100% know what that question mark does. And I feel like I should find that out, because I can't teach you all that stuff and then not completely understand it. Also, I don't know what the unwrap does. Maybe we see more description here. There's a lot. Yes, thank you. James, please explain. Function starts by using the split first to return a tuple. Yeah, so the tuple, and we unpack the tuple automatically. The first element, variant, is the byte. Second is the byte array. Yeah, okay, I think I understood and explained that quite well. Then the function uses try from slice from the payload. So we try to put that into one of those. Deserialize the rest of the byte array into an instance of node instruction payload called payload. Note that there is Rust syntax in this function that we haven't explained yet. OKUnwrapped and unwrap functions are used for error handling and will be discussed in another lesson. God damn it, James, in another lesson. Okay, but he says they're used for error handling. I mean, the or I understand. The unwrap, no, I want to understand it now. Unwrap is a shortcut. If result value is okay, unwrap will return the value inside the okay. Ah, okay. There we go. That explains it. And if it's an error, then it will panic for us and essentially, throw that exception. So basically what that does, this whole thing, the try from slice, if we have a look here, it will give us a result. And the result, we've learned last time, either has the okay or the error, right? So the result, can have a look at that. It's either the whatever or the error. So examples, get the okay. So this thing here, we can have a look in the actual source code. It either returns the okay if the deserialization has worked. If the deserialization has not worked because the types don't match, not enough data, or whatever other reason, then an error is thrown, right? So, or an error is returned. So it returns the error in the result. And what the unwrap now does is, if it is an error, then it will panic. And if it is not the error, if it's the okay, then it just gives back the result from the okay. So the payload itself, because the okay will contain the result. And we just want the result for the payload. Yeah, there we go. Made it, understood the unwrap. And okay or pretty much does a similar thing. But this is more like speaking. It's if that's not okay, then throw this error. Still don't know what the question mark does. Do we also want to find that out real quick? But that's harder to find out because I don't have a name for it. Rust, what does the question mark do? Rust, what does the question mark do? What is the question mark operator? Enables optional chaining. Well, that I understand. To immediately return error or none. Ah, okay, so it returns that error, then this probably immediately raises it, no? Something like that. But it's also connected with the error handling. We'll understand eventually. You can't understand everything on the first day. But I'm making a mental note that I want to understand what this does. But we're definitely learning here on the way. So all good, all good. And we were stopping here. Finally, the function uses the match and it creates the appropriate information from payload. Yes. So we had this payload thing that we deserialized our instruction data into, and then we can use the deserialized data to build that enum, which we then return. So far, so easy. Program logic. Now that we have that, we can execute different code based on our instruction at the entry point. So coming back, entry point, as we learned last time, this is where the program execution starts. We define a function as an entry point with that macro. And here it gets that instruction data. And basically, we just need to call our unpack. So the thing that we just implemented, from that we get our instruction. That is a node instruction. And then we can on that again do a match on the node instruction enum. If it's a create node with title, body, ID, then we execute whatever we want to do with title, body, and ID. If it's an update, we do the update code. And if it's a delete, we do the delete code. Pretty simple. And now you might be thinking, but I could have also done that in here already and executed my code here. Yes, you're right. And you do still want to split this. Here we're just building the enum such that we then have the final enum that we can work with like this. Just makes it cleaner. Of course, you can also just read the first byte of the instruction data directly and do a match on it. That works fine for me. And then just unpack the rest. But since the unpack depends on the first byte as well, so which instruction it is, might as well do all of that in the unpack. For simple programs where there are only one or two instructions, might be fine to write the logic inside the match statement. Yeah, if we have just a little bit of code here, then we can keep it like that. If we want to have bigger programs, then obviously we want to here just call yet another function, or actually call a function with that thing. Yes. Then program file structure. Now this is interesting because I think this is conventions. The program from the previous lesson was simple enough that we could just put it all in one file. But if we have bigger programs, then we want several files. And I think there are some conventions on the structure. So for instance, we could put each of our instructions in a separate file. Okay, so first James would split the entry point from the deserialization code, but we need to register all of our files in one location. That's why usually for bigger programs, the librs only contains like those kind of statements where use this, use this, use this, use this, and everything is in other files. Any declarations that you would like to be available will need to be prefaced with a pub keyword. So public for it is exported. I mean, we know that from other languages. In Java, you also call something public if you want it to be visible from other classes, or that's similar to the export in TypeScript. We just want to make it visible to the outside world by making it public. And here essentially we include this entire file instruction as a module. Yeah, module in crate in package. Remember last time. With all that knowledge, we can now finally write our first somewhat more complicated program and not just a print hello world. And we will create the movie review program that we were using also in the previous lessons. I think up here we were interacting with the movie review program. But we had the movie review program already deployed on DevNet by James. Now we want to write it ourselves. Yes. And the way this is gonna work, we do this the same way as we also did for front end. I will be I will be doing this. I will be implementing this alongside James here at the demo. Of course, not just copying code, but trying to do it myself. And then in the end, you will get to do the same for the student intro program, such that you don't just copy my code or James's code, but that you can try it by yourself. But first, you can watch me attempting to write all of this code without first looking at it. Let's do it. Of course, we won't be finishing the program today. We'll just focus on the deserialization of instruction data, but in the following lessons, we will finish it. So here we will then also in the demo do the movie review, yes. And then in the third lesson, does that also contain movie review stuff? Yeah, I guess so. This will follow us in the next 2 more lessons, this program. And today, we just do the deserialization for our movie review program. Step 1. We will again be using the Solana playground, and we still have the code from last time here because cookies. So we just remove all of that. But actually, I might want to put it somewhere, just so I have that saved somewhere. I'm gonna create a new one. Oh, my movie review program. Okay, inside librs, we're going to bring the following crates and define our entry point to the program. So, I mean, I don't need to know everything by heart, right? And especially having like this. I'm just gonna, so the entry point, and here we define our process instruction, which takes, I mean, I could copy this from last time or copy it from this time. Again, takes program ID, accounts, and instruction data, and we'll just say okay. So that's my entry point. Now, unfortunately, if I were to try and build this, then it would say, well, it doesn't know most of those things. It doesn't know that. If we try to build it, it will tell me, cannot find this. Have you considered importing it? But unfortunately, the playground is not smart enough to let me just import it here with a click as I'm used to from my IDE, like Visual Studio Code or something. So I'm just gonna also copy this part because I can't be bothered to, do this manually. This is not the thing that I want to be able to do by myself, just writing it down. This can easily be Googled, how I can import all of that. Use those crates and those modules. And then if I build it, then I still get warnings, but it's built successfully. Now let's do the more interesting stuff. We want to deserialize instruction data. For readability, we create a file instruction.rs. Inside this file, we'll use this and then create a movie instruction enum with an add movie variant. Okay, now that's something that I want to be able to write by myself, not the import, but the rest. So we create a new file in here, instruction rs, import this, and now we said a movie instruction enum. So enum, movie instruction, and one of the instructions that are possible is a add movie review, and this variant should have title, rating, and description. So this variant should have title, which is probably a string. What did I say? Rating? Rating, which is byte, so a U8, and description, which is again a string, I suppose. Cool, if I don't have that here and I save, then it puts it here. Hehehe, funny. Does that compile? Yes, but I also didn't include it yet. I need in the lib, I need to say, how did it go? Pub mod. Whoa, it just puts it in one line there. Okay, why not? And that won't compile? Oh, it does compile. Okay. Oh, because I don't use anything from there yet, so I don't need to have it public. Okay, cool. If I now had an error here, cannot find this type. But if I weren't including that, then it would build successfully. Haha. Only if I include that, if I say pub mod instruction, that it also includes this file, then it doesn't compile anymore. So good. So that seems to be working. Perfect. Change that back to U8. Do I want references to a string or do I want strings itself? I'm not sure. Here they have strings themselves, so it should probably be fine. Yeah, what else did I want to do? I think that's good enough. Let's check how we did. I think we did well. Oh, he made it public such that we can use it somewhere else. Let's make it public. Fine. Such that outside I can then use it. Like this. Use of undeclared crate or module. Oh, I just can't type. That's my problem. There we go. That's better. And if that wasn't public, then I would get private enum as an error. I cannot use this. Enum is private. So per default, it's private unless you define it as public. Same way as per default, it's immutable unless you define it as mutable. That's how Rust deals with stuff. Yeah, cool. Moving on. That's that. Then create an implementation for the movie instruction enum that defines the implementation, implements a method unpack that takes a byte array as an argument and returns result type. So just do this for now. We want an implementation for our movie instruction with one method unpack. Okay, so we want an implementation for our movie and our function unpack. Do I need to call it public? Probably public function such that you can call it. Yeah, he also did it public. Takes a byte array as an argument. Byte slice, not an array. I'm gonna be very since I now learned the right terminology, I want to use it. And returns a result type. So unpack takes an input. How do I define types with a double point, right? Which is an array of U8, but it's a slice, a reference to an array, a slice of undefined length. Oh, that's all I need as an input. And as an output, oh wow, it makes it to that weird error. Sure, why not? We get a result of, how would I do that? Okay, or error, something like that? Nah, that's not how you write it. I want more syntax highlighting and suggestions. There I write my code, but that doesn't look right yet. Wait, what exactly should it return? I mean, scrolling up and looking here is pretty much as stupid as just scrolling down. I mean, we were close. We were close, but... So on success, I want to return a movie instruction. And since I'm building myself here, I can just say self. And the error, I can be more specific and be like, make it a program error. And then we do essentially the same thing with a split first to get the variant, so the instruction. Let's do it. So let I call it instruction byte and rest slice. The input, what's it called, split. I don't have a autocomplete. This is annoying. I'm looking forward to the time where we implement locally and I have a proper Rust IDE. So split first, and then there was the OK or, and then the program error. I mean, I could just copy that, or I'm like, it will work like that anyway, haha. Okay, or program error. How do I instantiate this thing? Oh, it does not give me any. I need to copy this because it won't let me. There we go. And then the question mark that I still don't know what it does, but I'll just use it. I'll just abuse it. And I kind of also want to always test it. Oh, it doesn't even compile, so that's great. Expected enum result found. Oh, because I don't return. Yeah, that makes sense. How do I just say error to this? Do I need to instantiate that? No, just return error. Yeah, so there we go. Then it compiles. We have a compiling program. And I kind of want it to... Oh, you don't see my mouse either? No, you do see my mouse. Weirdly as a thing here. You see this black. I see this white. That's so weird. Anyway, so essentially I always throw the error now, but I kind of just want to test if that already does what I want it to do, because otherwise we don't learn. So, gotta build some front-end code. Or should we do it directly in tests? That's gonna be a good practice to do the client-side stuff as well. Does the PG wallet, I'm just gonna use the PG wallet. I don't need a new key pair. I'll just create a new instruction with keys. Did the movie thing need? First of all, our program doesn't do anything yet anyway, so we don't provide any accounts, but we do provide instruction data. So the data, how did we create the buffer again? I mean, that's essentially what we did in module 1. Let's check if I still have that code. There, module 1. No quick survey, thank you. When did we do that? So the buffer alloc, that's what we need. We need a buffer. That's my instruction data. And how about we just send 1 byte for now and send the byte 0. Nah, let's send the byte 42 because at least then I know that I read instruction data right. So we put that instruction data into the transaction. Transaction calls my program without accounts. This instruction data, put it into a transaction, and we send and confirm that transaction, and we sign it with our key pair. That seems good. Seems like a simple little test. Now, for that to actually work, we of course need to wait. Let's check if I can run this. Oh, that's the client test. There we go. Failing. Attempt to load a program that does not exist. Yes, because obviously we did not deploy a program yet. So we need to go here. That's already looking good. We build it, we deploy it. Nice. And now if I hit the test, I have 1 passing. Nice. To actually see what's happening, we can check Explorer. My program for now does nothing, so all it does is give an OK. But I should see this. Where's there an exclamation mark? Mainnet is good, but DefNet does not look so good. Source scan. You got any better info for me? Yeah. Explorer just doesn't want to provide me with that information, so let's go here. 2 minutes ago, we called the unknown instruction of Jake, my program, and the instruction data is 2a, which is 2 times 16 plus 10, 32, plus 10 is 42. Score. So that's 42, 1 byte, 42 hex. By the way, if you don't know what I'm doing here, I'm converting from hex to decimal. And that worked. My program was called. And now I also want to test if my instruction unpack here works. So I'm just gonna call the movie instruction unpack. Since here I did not provide a self, this is a static method in the movie instruction, and it takes the instruction data as an argument and it returns a result. Should we just log that? Is that possible? Expected string found result. How do I let it print now? Does that work? No. Cannot be formatted by the default formatter. Does it have an unwrap? But then I get the movie instruction. That's cool. Okay, so I get the movie instruction, and the movie instruction cannot be formatted, which is fair enough because that's my enum. You think if I implement a toString like I would do in Java, you think that would help? No, but I could then manually call the toString. Cannot be found. Oh, wait a second. Returns a string. Try using a conversion method. Expected string found reference to string. How is it to string? How about this? Okay, good. We're getting somewhere. Now we're just missing this because in Rust we need that. Otherwise it tries to return something here. Ha ha ha. Okay, this is looking better. Can I now leave this out as well? No, I need to specifically call toString, but that works. Okay, if I'm upgrading this again, and hopefully that works without having to create a new program ID, because I like my program ID, but I might have the same problem as last time, that probably the playground doesn't want to resize accounts or something like that. That's not looking good. That's definitely taking way too long already. Yeah, and then we get the error with no specific issue. So we just create a new keeper here and then deploy to this one. That then works. Amazing. And if I now test, then I get failed. Transaction simulation failed. Program failed to complete. Well, that's obvious because here I just return error all the time. I could instead use an OK, and then I need a movie instruction. I'm gonna do movie instruction, the only movie instruction there is. How do I write this again? No, you know what? I can't be bothered to do this yet. I'm just gonna do, for testing purposes only, gonna do this. And then I don't need that. Let's try. Test. Ha! Now it passed. Amazing. Really, that was the error. I mean, I knew that that was an error, but that was the only error. That's what surprises me here. So if we check that, then we see that we called that program again. And in the program log, we see result is I'm a movie instruction. That's what we expect because we write here result is, and then here I'm a movie instruction. I don't say which movie instruction I am here. I'm the invalid movie instruction, but still, I'm a movie instruction. So this already works. I want to do another message here while we're at it, calling instruction and then the byte. Let's see what that hands me. Oh, that doesn't even compile. Oh, because I didn't include it. Solana program message as well. And I keep forgetting those. There we go. Nice. Test it. And then we see calling instruction 42. That's pretty nice. We call instruction 42. So we can get the byte out from there. That's actually pretty sweet. I'm a bit confused as to why here this is a reference to the variant, because I just get out the byte directly. I mean, would that make any difference whatsoever if I were to get that as a reference and not as the byte itself? I mean, it's just a byte. If that's copied over, it's probably even more efficient to just use the byte than to work with references here, but I want to understand what the real difference is. Let's look at James's code. Yeah, he also does it with a variant, with a reference. If I were to use a reference here though, in my instruction byte, if I make that a reference, then I build it, then I upgrade it, and then I test it with a different value. So we got 43, and that also works. There is no difference, I guess, except for how it works under the hood. I think if I do it like that, it would keep a reference to that original array. And if I do it like that, then it copies the byte over into this variable or constant, into this immutable variable. Not so variable anymore then, huh? But it works either way. So I'm good with that. I'm good with that. Just to also test if that now works or how that would look if in my test I would call it without instruction data. So if I would not provide instruction data, then I would get the error, program failed to complete. Doesn't really show me more, but that's because in here this thing is thrown. Cool. That's that first part, I would say, done. Then deserialize the rest of the array into an instance of movie review payload. Movie review payload. Oops, I guess I skipped that part, but it's literally just that. A movie review payload. The important part here is this, where we derive the Borscht deserialize onto it such that we can deserialize stuff into those fields. And again, order is important here. So we start with, we have the rest of the slice and we want to deserialize it into a movie review payload. So do I already know this by heart? Try from slice is a function of this thing. So I can say this and then try from slice, right? I guess, I hope so. And I think this will just take the rest of my slice. And then this will return me a result again. So I can unpack or unpack. What do you say here? Unwrap. We unwrap it to get out the movie review payload itself, or otherwise throw the error if that doesn't work. So that's our, yeah, let's just call it payload. Why not? Don't return. That's then that thing. And now we just need to build it. Again, we can do the match in here, or if we know that let's do a match. Let's do a match on the instruction byte. If it's 1, let's say, I think James did it with a 0, but is that the right error? Yep. Then we return a movie instruction, or I could also write self here, add movie review with the title being payload, title, rating and description being payload, rating and description being payload. So just get the stuff out from the payload, put it into the actual movie instruction, namely the add movie review. If it's not that, but it's anything else, then we use this thing and we save that as the result or movie instruction. And we say, okay, with this. I would probably throw an error here instead of this, but for debugging, I keep this for now. Let's see if that compiles. Nope. Unreachable statement. Because we return here? Or what? Can I make a match that returns me something? Oh, he does it with OK. Well, yeah, but then it returns something, right? So here I return this thing. Here I return this thing. That I store in here. Unexpected token. I think I'm missing this. The comma separates the individual cases of the match. Try that again. Wait, where's that error? Do it again. Oh, of course. I'm again missing this is still just one thing that I don't want to return yet. So I need that semicolon. That's better. Wow, Rust is really picky on those. I kind of like it because it's not like JavaScript being like, yeah, whatever you say, I'm trying my best. Rust is like, no, you better put that here. Otherwise, I'm going to return this, which I actually prefer if it's honest with me, telling me what I am doing wrong. So we have this, which we match here. So this returns the one of those. And okay. Let's see if we can then actually make a movie review. Cool. If I now run it, it will probably fail. Yep. Because obviously the try from slice will throw me an error. Now I would really like for the error to be more verbose. Like even if you're doing pre-flight checks, you could tell me more about why the program failed. I haven't yet figured out how to do this with Playground too. So I'm just gonna work with more heavy paths. In fact, let's do the actual payload unwrapping only if we have instruction 1. How does that sound? Can I do that? Nope, also fails. Maybe I just didn't wait long enough. Nope, keeps failing. Oh, because I still have that commented out. Well, obviously. There we go, now we're passing. But it would be now kind of interesting for me to have that a bit more verbose. Can I now match myself here? Let's see. Match self. How would I do that? Movie review invalid. Then we return this. Else we return this. And now we want to return, so I don't put a semicolon here. And I just return this string. Just here for testing purposes. This invalid. Build it. Upgrade it. Wait a few seconds for them to realize that I have a new version deployed. Then test. Oh, Block hash not found. Well, that's something that can be fixed. Cool. Let's see. In SolScan, I need to wait for max confirmations until I can have my program log displayed, which is weird, but there we go. So we're calling 43 and result is I'm just here for testing purposes. So this is working well. Great, that's working. And if I add, so if I don't do 43, but 1, which is the instruction that should deserialize that stuff, then it's failing. If I do 2, then it gives me the invalid one again, but this one is passing. So that's cool. Okay, now we just need to provide some more instruction data for the actual title and rating and description. Again, gonna just look here. Did we ever build like something with Borscht? What was the serializing? What lecture was that? Serializing the 4 and 5. So 4 there, something like that. Something like that. So in our test movie schema, do you have that? Oh, if I don't have that in, then I might get a problem. Okay. Can I do stuff like npmi here? Okay, I'm just gonna manually construct me that buffer because I'm a pro and I know how this stuff works, lol. We're just gonna do the minimum effort whatsoever. So we just need 2 strings and another byte. That can't be too hard. So the minimum string is like a few letters. So let's do, I mean, I can make the buffer too big. That's not the problem. But even if I had it at the correct length, it doesn't matter. So, oh wait, no, I need this. And then I can just write stuff. So a string consists of a u32, the length. So we write a u in 32, little endian, the length. Oh, we're in JavaScript. I don't know, let's do 3 with offset 1. Oh, other way around, offset here. And then we write the actual string. So string to write to buff at offset, but where is offset? We'll see. Let's write ABC offset 1 plus 4 plus title length. And then, no, the title length, not yet. I'll save the offset. If you don't understand what I'm doing here, it doesn't really matter that much. So that's where I then write the data. That's where I write the actual string. And then we write another byte for the rating. I can do like this again. Or we can just write 1 byte, but it's the same thing. So I give it 5 stars. Why not? Add the offset. And then we write the actual string. 10 letters. This is great. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ha! Perfect. That works. That's what you gotta do if you cannot use the Borscht serialization in JavaScript. But that's fine. And then we just plug in our instruction data here. And now let's test this again. Damn it, we're still failing. I was hoping that we don't fail. What's the total offset now? We have 1 plus 4 plus 3. 1 plus 4 plus title length is 3. Yes, I could do the title up. Fine, let's use the freaking variable. Plus 1 plus 4 plus description length. It just formats that, okay. Then we have the correct length here as well, if that was the issue, which it kinda was, but kinda wasn't. Uncaught error, resize observer, loop limit exceeded. What? What's happening here? It says I'm a movie instruction, so that looks good. Maybe my buffer just really was too big, and then it also gave me the error because it didn't fit exactly. Does that make sense? Maybe? Not sure, but that would be weird. Wait, I write the length to the offset. Oh, that's weird. Hold on. Here I need to do plus equals 4 first because I just write the AU in 32 here. That's one error, but still. Okay, test it again. Okay, now it's working. Okay, so maybe that was just a internal JavaScript thing because I was writing over my buffer here. Obviously, because I had the offset too far and I put it on the right size. If I were to add 100 here, does it then not work anymore? Yeah, that's weird. If the buffer is too big, then it doesn't work anymore. Okay, learn something new. Even if I just add another byte that is not used? Yeah, it needs to have the exact right size for it to Succeed. Right, so we need to have the correct size buffer and we put some data in there. And now we could actually properly log this as well. If in here we say we can be more specific, we can match on the movie review with title, rating, description, because I'm lazy. Or does it need to have the exact same names? We'll see. And then I just say, how do I format a string though? Can I also use this inside here? TRD. Can I do that, you think? Will that compile? I don't think so. Yeah, okay. Missing fields, title, rating, description. Okay, so maybe I need to have them title, rating, description like this. Oh yeah, and then I need to also rewrite this, of course. But like this doesn't work anyway. Hold on. Yeah, like this it compiles. Like this it doesn't. Okay, cool. How can I create a string, a formatted string like this? For formatting and printing strings at runtime into strings. But does it give me a string as a result? We shall see. Can I do this? Yeah, I can. Title, rating, description. Nice. Let's build it, deploy it, and then test it. Here we go. We got a transaction ID, a signature that we can look up. After we've got enough confirmations, we can see add the movie. We have an add movie instruction with title ABC, 5 stars. This sucks. Nice, because that's exactly what we've written in here. 5 stars, ABC, this sucks. This is amazing, but that didn't fit into my 10. Wow. This is amazing. Gotta make my description longer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. So that's 16, please. That's all I need. See, that's exactly why you use those constants here and then you use them everywhere, such that you only need to change them here once. Even better would be to read the length of this actual string, but whatever. Yes, yes, yes. This is amazing. Let's see if that also works. Also works. Boom. This is amazing. I love it. Cool. We can pretty much deserialize our instruction because here we just get back a movie instruction. And then based on this movie instruction, we can now do the things that we want to do similarly to what we did in here in the toString. If it's the add movie review, then we do something with it and so on and so on. What else is there to do, James? We did that. We did that. We did that. Or return a program error otherwise. Okay, so let's fix that it's consistent with what James wants. This needs to be a 0, and otherwise we actually, if I don't want that to go in here, can I here just then say return error with this sort of an error? The return then has more power than this, right? I guess so. Now let's see, does that build? Yes, let's upgrade. Which means if I test now, it should not work anymore. Only if I put the instruction to 0, then it should work again. Yep, here we go. And that's that then. Yep, I guess that looks very similar to what we have. Nice. He does the OK directly. We store it first and then give it OK here. I find that a bit more obvious. By the way, you can also just not have this and not have the return, just like that. That does the same thing, also compiles. I said before even checking if it actually compiles. We have a bunch of warnings. Oh, because, yeah, for instance, we are in Rust. We expect stuff to be written in snake case, like this. Where do we use the Deserialize? Here. Snake case. Yeah, okay. And since we don't use these things, we can do this. And what other errors do we get? Looking at errors is also good to learn, I guess. Unnecessary parentheses around match. Okay, so you say, I could just say match instruction byte because you don't, there's nothing more. Okay, fine. And then the same with self. I'm just so used to it from like Java where you need those for syntax. There we go. Now it compiles without warnings. Perfect. Is that it, James? Are we done? No, program logic. With the instruction deserializing handled, we can return to the librs to do some of our program logic. Remember, since we added code to a different file, we need to register with yes, we have done that. And then we can use the use to bring the movie instruction into scope. Also already done that in here. Let's define a new function add movie review that takes all the arguments, program ID, accounts, title. It should also return an instance of program result. Then inside this function, let's simply log our values for now and we'll revisit the rest in the next lesson. Okay, I mean, yeah, so essentially we just want to return an instance of program result. So really what we're doing here is creating a, again, snake case, because Rust, and it takes the title, which is a string, the rating, which is a U8, and the description, which is a string, and it should return a program result. Did we import that? Yes, we imported that. Okay, cool. Do we need to say what of the program result? I guess they handle that. So all we do here is nothing. Essentially, we do this, adding the following movie. And then, oh, and now I already have the description. Well, then let's just log the title. And essentially, I could do stuff like instruction is result unwrapped, and then I match movie instruction for movie instruction. What did we call it? Add movie review. So essentially this. And there we call the function add movie review with title, rating, and description. So that's a pure writing exercise here. Match that. That's it. Oh yeah, this will not compile. We have two errors. First one is we expect a program result and we don't return. So wait, is okay not a program result? Where did you find that? 26. Oh, here we want to return. Ah, right. Also, we do want to return what comes back from the match. Okay, so we just return that. Don't return the OK, but put the OK in here. So we just say OK here, because that's a program result. And we return that. Yep, so that's the first error fixed. Then the second error is that the match arm, blah, 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 blah. So I guess that here, first of all, I have the wrong thing. Yeah, that's that. And then I don't exhaust all patterns. As we heard in the beginning, the match must have one path for each possibility. And here I don't have a possibility for my invalid movie instruction. So I could, add this here, the invalid movie instruction, but we don't want to ever use the invalid movie instruction anyway. So the alternative is to not allow this anymore. And if we save that and build it, then it builds successfully. We still have some warnings like unused variables. Yes, unused variables. Okay, fine. So if we don't use them, then might as well do this, haha. And then it compiles again without warnings. We will use them eventually. So let's upgrade this one last time, hopefully one last time, and then run my test on it. See, I prefer Explorer because it doesn't let me wait so long. Well, except it lets me wait like forever right now. Doesn't do definite at all right now. Here we just have the adding the following movie, ABC, calling instruction 0, because that's what we do. Cool, that all works just fine. I'm happy with that. I feel like I learned quite a few things today. I could have done this also without going through that course. But going through this gives me more of the detailed nuances of Rust. Right? I learned a bit more about the inner workings of Rust. Could I have programmed this program relatively quickly without? Yes, but understanding Rust really helps. And it just takes time, and you need to repetitively do stuff to actually make stuff happen. Oh, he had the entire add movie review. Is that your entry point, James? No, that's your entry point. And you add movie review, but you also provide the account, the program ID and the accounts. Was that described here? Oh yes, I just didn't read it. Okay, fine. I'm good with it. We'll add that next time when we need it. Feel free to use this script. Anyway, that's what you can use if you don't want to write that ugly code in Playground. And speaking of practice and just writing more code yourself, there's the challenge where you essentially do the same thing just for the student intro program. And I really encourage you to try this out because you do learn a lot by writing the code yourself. Reading code and watching me code is one thing, but then actually writing it, you will make mistakes yourself, and then you will realize, oh, I constantly forget putting semicolons, or yeah, whatever it is that you learn. So yeah, try it out yourself. Go do some coding, and I shall see you for the next lesson. We're done with this. Next time we'll do some state management. So I really hope that you enjoyed this video. If so, give it a like. Give it the somewhere here is the like button. And subscribe to my channel. I post more of those videos because James is publishing a lot of those classes here. So, gotta keep up with that. And yeah, there's more exciting news coming up. I also play the game of death. If you're interested in hacking Solana contracts, join my Discord, watch the game of death intro video, and looking forward to seeing you around. Looking forward to seeing you in my Discord, playing the game of death, and doing the Solana development classes with me. So yeah, I'll see you in the next one. Check out those videos and enjoy your life. Touch some grass as well and learn some Rust. Basically, I just want you to stay curious. Stay curious, learn more about Solana or anything that you're interested in. I just so happen to be interested in Solana development. That's why I learn about this, and I want to take you with me on that journey. So I'll see you in the next episode. Till then, peace.